You can start.
Okay. What we did last time, we did the non-graphical problems. This time, let us do even more interesting thing. Are you able to see the screen?
Yeah, Uncle, I'm able to see the screen.
Okay, now we will do the solution of the LPP by graphical method. So graphical method, what is the constraint? Only for two values. Okay, if the constraints are or decision variables are only two values, x1 and x2. Only then you can do that. If there are more than two values in decision variables, you can't do that. But constraints, you can have as many constraints as possible. And each constraint will become a line on the graph. Okay. So, but only linear programming we can solve using graphs. Because that is linear programming means only two decision variables, x1, x and y, or x1 and x2. In our case, we call it x1, x2, x3. No, so only x1 and x2 is there. Then you can solve that problem graphically. Now, what additional thing you can do is from the graphical method, you can use the points of intersection and other things and find out the feasible region of the solution. The region within which the solution is feasible. Among them, you can find out the points which are either minimum or giving maximum value also. So the values of x1 and x2 for which z is maximized, that also you can find out, okay, by based on the graph method. But if you have x1, x2 and x3, if they give x1, x2 and x3, three decision variables are coming means then three or more, then graphical method is not possible. You cannot use a graphical method. Okay. So right at the beginning, you check if the decision variables are only x1 and x2. If more than two decision variables are coming, graphical method is not possible. Okay. Okay, what to do? How to do this thing? You know what is decision variables. You know what is object function. You know what the constraints are. You know non-negative restrictions. All that you know. See, same thing in the non-graphical normal method. You have the decision variables. Then you have the objective function. I'm underlining in blue. Okay. Then you have constraints like this. 1000x1 plus 1000x2 must be greater than or equal to 16,000. Then non-negative constraints like x1 plus x2 must be greater than those. All of that. Okay. Now, state the problem mathematically. If they are not given it correctly, you must state it in terms of objective function and constraints and restrictions. Okay, that is what he's telling. Then write all the constraints in the form of equations and draw the graphs. A single graph only you will be drawing. Okay, in the usually because x1 is greater than 0 and x2 is greater than 0, the graph will be drawn in the first quadrant. See, last condition usually says x1 greater than 0 and x2 greater than 0. That means your graph will be in the first quadrant. Okay, somewhere like this only graph will be drawn. You do not have to draw it anywhere else. So that's one important thing. Find write all the constraints in the form of equations. Okay, that means for each constraint, suppose one constraint says 3x1 plus 2x2 is equal to 5. This is or less than or equal to 5. Okay, what you have to do? Less than or equal to, you cannot draw on graph. You must say equal to 5 and then draw this graph. 3x1 plus 2x2 is equal to 5. Okay, how to draw this graph? First, you take x1 equal to 0. Then you will find that 2x2 is equal to, let us say this is 10. Then you find that 2x2 is equal to 10. Then x2 is equal to 10 by 2, which is 5 you will get. Okay, so x2, when x1 is 0, x2 is 5. Like that you can get. Okay, so 0, 1, 2, 3, 4, 5. So you get a point, 0, 5. So you get 1 point, starting point or something. Okay, for the line. Like that now, x2 is given, you can find x1. So 3x1, and now x1 is 0. So x2, now take x2 is equal to 0. So 3x1 equal to 10. So x1 is equal to 10 by 3. Like that you can put. So when 10 by 3, comma 0. This is the other point. Okay, so you go to 1, 2, 3, 4, 5. 10 by 3 is 3 and 1 half. 1, 2, 3. So here is your other point. So this line joining these two things will be your line. What is this line? 3x1 plus 2x2 is equal to 10. This is the line. So that, see, you understand now? Each line you can draw like that. Each of the constraint is a line, and each of the line you can draw like that. Okay. Another constraint you can draw like this. Third constraint you can draw like that. Okay. So you get these constraints like that. Then you can find the, if you want to maximize thing, then this becomes the region for maximization. If you want to minimize this thing, then this becomes the region for minimization. Okay, like that. So this becomes the minimum. This becomes the maximum. Okay, then this point A, B, C, and D point are there. Among these 4 points, this is the feasible region. This becomes the feasible region. Solution feasible solution. So in that, among them, A, B, C, D, 4 points. Find out which of them is the maximum. Then you get the maximum function for Z. Okay, like that you have to do. Okay, we will do one problem. So find the coordinates of each vertex of the feasible region. Okay, that's what I told you now. So this is the thing. Then one line is going like that. Another line is going like that. Okay, then what? This becomes the feasible region. Okay, A, B, C, D. These are the points of the feasible region, the coordinates of each vertex. So A, B, C, D are the 4 vertex. Find the coordinates of the 4 vertex. Okay, A will be C 0, 0. Okay, then B, you have to find initially what line came here. No, this point, this point. Then this point you found out differently already. So C you have to find. How to find C? C is the intersection of the first constraint and the second constraint. Suppose the first constraint was 2x1 plus 3x2 is equal to 10. Second constraint was 6x1 plus 15x2 is equal to 100. Okay, these two lines you solve for these two lines. Okay, simultaneous linear equation is solved. You get the intersection points x1 and x2. That point x1 and x2 only is this point. Okay, like that you can get all the 4 points. After you get all the 4 points, by substituting these corner points in the objective function, we can get the values of the objective function. Suppose they had given, no, this is what is given. The maximizing function is 4x1 plus 12x2 is the maximizing function. Okay, what is the value? You all these 4 points, you put x1, x2 values and find out which one z is the greatest, which one z is maximum. That one value of x1 and x2. That is the solution that you are wanting. If the problem is maximization, then the maximum of the above values is the optimal value. If the problem is minimization, then the minimum of the above values is the optimal value. Okay, now if you start doing a problem, you will easily understand what we are talking about. One simple problem you'll do. Okay, then you will see the solution. Let us solve example 10.5. Okay. Z is equal to 2x1 plus 5x2. Let us do this sum. Okay. Example 10.5. Now, what is a maximizing function? They are given it. Okay. 2x1 plus 5x2. This is the maximizing function. You'll have to find out various values of x1 and x2 and see which one z is maximum. Subject to the conditions. What are the constraints? First constraints, x1 plus 4x2 equal to 24. Okay, you drop out the less than, you cannot use that. What is the second constraint? 3x1 plus x2 is less than or equal to 21. Again, you drop out the less than or equal. And what is the third constraint? x1 plus x2 less than or equal to 9. Okay, this is third constraint. Okay, then of course we have the usual non-negative constraints, x1 greater than 0, x2 greater than 0. Okay, because x1, x2 greater than 0, we will always find that they are always found in the first quadrant. Okay, that's one. Now let us do some work. Okay, how to find out the solutions for x1 and x2. In this case, this is a linear equation. Okay, first linear equation. Okay, first you take x1 equal to 0, then what will happen? 4x2 is equal to 24, it will come. So x2 is equal to 24 by 4 is equal to 6. So what is the point? When x1 equal to 0, x2 is equal to 6. Okay, so what happens? Let us say 1, 2, 3, 4, 5, 6, and 9, 10, like that you can put. 1, 2, 3, 4, 5, 6. This is one point for the first line. Okay, 0, 6. Okay, then now you put x2 is equal to 0. Then what happens? x1 equal to 24 it becomes.
Uncle, how come x becomes 24?
If x2 is equal to 0, x1 plus 4 into 0 equal to 24. Okay. x1 plus 0 equal to 24. So x1 equal to 24.
Oh, okay.
Correct. Okay. Now we cannot do this thing. Okay. Let me do it differently. We'll take 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Like that you take. Same way 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 you take. Okay. Now this becomes 24, 0. Okay. 0, 6. This becomes 0, 6. So 0, 6 to 24, so you draw one line like that. Okay, draw one line. So that line only is x1 plus 4x2 is equal to 24. First constraint is like that. Now do the same thing for this line. x1 equal to 0. So 3x1 becomes 0. x2 is equal to 21 it becomes. So first point is 0, 21. Now x2 is equal to 0. Now what happens? 3x1 equal to 21. x1 equal to 21 by 3, that is equal to 7. x1 equal to 7. So this point becomes 7, 0. So first point is 0, 21. Second point is 7, 0. 0, 21, how you will mark? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This is 21. So 0, 21. This point is there. Then second point is 7, 0. 2, 4, 6, 7. This is 7, 0. Okay. So the second line is like this. Okay, like that you join second line. Now what is there? x1 plus x2 is equal to 9. You have to find 2 points in order to draw that line. x1 equal to 0, x2 is equal to 9. Okay, x2 is equal to 0, x1 equal to 9. So 0, 9 and 9, 0. Those are the points. 0, 9 will be what? 2, 4, 6, 8, 9. This is 0, 9. Okay, there's 2, 4, 6, 8, 9. Again 0, 9. 0, 9. Okay. So join this one with this one. Okay. Now what you get? You get this. This is the region of feasibility that you are getting. Okay. 2 points you have to find out. Okay. This is a 0, 0. Okay. Let us say this is A. This is what was that? 7, 0. No. 7, 0. This is B, 7, 0. This is C. This is D. What is this? We have to find out. C, have to find out. And this is 0, 6. This is E, D, 0, 6. Okay. So that is a feasibility region. Now you have to find C and D. How to find C and D? What you have to do? You have to find the intersection of this point is the intersection of line 0, 6 and 24, 0. So first line. So first line, okay, intersection, that is sec x plus 4x2, x1 plus 4x2 equal to 24, intersects with the third constraint, x1 plus x2 is equal to 9. Okay, so you solve for that minus. When you minus, what will happen? x1 will go off. 3x2 is equal to 24 minus 9 is 15. Okay, x2 is equal to 15 by 3 is equal to 5. Okay. Now you find x1. x1 plus 5 is equal to 9 in this equation. Okay. x1 is equal to 9 minus 5 is equal to 4. So what is that point? 4, 5. This point first one round, no, where the first intersects with the third. This is 4, 5. Okay. Same way you have to find point C. Point C is the intersection of 0, 9, 0, 9. This line, okay, x1 plus x2 is equal to 9 intersects with point C with the first line 7, 0, 0, 21. Okay, it was second line. Okay, with this line. So 3x1 plus x2 equal to 21 and in this one intersection. Solve these two. Just minus this. Okay, this will go cut off. So 2x1 is equal to 21 minus 9. It will be 12. x1 is equal to 12 by 2 is equal to 6. So okay. So x1 plus x2 is equal to 9. So 6 plus x2 is equal to 9. x2 is equal to 9 minus 6 equal to 3. Okay, so this one is equal to 6 and this one is equal to x2 is equal to 3, x1 equal to this. So this point is equal to 6, 3. Now what you have to do is telling maximize z. So z max you have to find out. Okay, there are how many points are there? 0, 0 is a point. Okay, then 7, 0. It is point A. 0, 0 is point A. 7, 0 is point B. C is 6, 3. D is 4, 5. And E is 0, 6. Okay. For all these points, you have to find the value of Z max. Okay. What is Z max? 2x1 plus 5x2. That is only Z max. 2 into 0 plus 5 into 0 is equal to 0. Okay, that is the first one. Then 2 into 7 plus 5 into 0. That is equal to 2 into 7, 14. Okay. Then third one, 2 into x1 is 6 plus 5 into x2 is 3. 2 into 6, 12. 12 plus 15, 27. That is the third one. Then fourth one, 2 into 4 plus 5 into 5. 2 into 4 is 8. 8 plus 25, 33. And the last one is 2 into 0 plus 5 into 6, that is equal to 30. If you maximize this, which one of these is maximum? 33 is maximum. Okay, so D 4 comma 5 is the maximum point. This is the maximum point. So Z max equal to 33 when x1 equal to 4 and x2 is equal to 5. This is the answer. Okay. Maximize Z max. Done. You understood that problem? Once you understood this, everything else is similar only. Constantly keep doing the same thing. Only thing is, one example for maximize you have done. We should do example for minimize. Minimize will be the opposite way of maximize. Most of the things will be same, but one or two things will be different. So example 10.6 is the minimize function. Solve the following LPP by graphical method. Minimize z equal to 5x1 plus 4x2. See, this problem also we do, then we'll know everything. Subject to constraints, 4x1 plus x2 is greater than or equal to 40, 2x1 like that. Let us do this sum. Okay. Solve the problem by LPP. What we have to solve? I have to say example 10.6. Okay. Z 5x1 4x2. This has to be maximized. Okay. No, this has to be minimized. Okay. The smallest value for that for x1 and x2, so that z is smallest, we have to find out. Okay. Constraints are 4x1 plus x2 equal to 40. This time it will be greater than or equal to 40. Okay. Then 2x1 plus 3x2 equal to 90, greater than or equal to 90. Okay, there are only two lines now. Okay, x1 greater than 0, x2 greater than 0. So that is in the okay. It's in the first quadrant. This one also. Now what you have to do? You have to solve for this. Put x1 first. Find out x1 and x2. No, so x1 equal to 0. That means x2 is equal to 40. It becomes. So first point is 0, 40. This line first point is 0, 40. Then x2 is equal to 0. Then 4x1 equal to 40 it becomes. X1 equal to 40 by 4 is equal to 10. So what is becomes 10, 0 is the other point. 0, 40 and 10, 0. Okay. 0, 40 is a very long distance. So you must be very careful. Or x1 plus x2 40 and 90. Okay, now we'll put 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. 0, 40. So 0, 40 is there. The other number you have to do now is 10, 0. You put 1, 2, 1, 2, 4, 6, 8, 10. This is 10, 0. Okay, so this is how you should. Now you have to join this thing. Okay, first line you got. Now 2x1 plus 3x2 equal to 0. x1 equal to 0. Then what? 2 into 0 plus 3x2 is equal to 90. So 3x2 is equal to 90. x2 is equal to 90 by 3. That is equal to 30. x2 is equal to 30 and x1 equal to 0. So 0 comma 30 is one point. The other point is put x2 is equal to 0. That means 2x1 equal to 90. Then x1 is equal to 90 by 2 is equal to 45. So the second point will be 45 comma 0. Okay. So 0 comma 30 will be joined to 45 comma 0. Let us go 0 comma 30. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay, this is 0 comma 30. Then this side 45 comma 0. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. So 45 is here. 45 comma 0. 45. So join these two lines now. Okay, now that two lines are joined. Okay, now this is a minimal function. So which is the feasible area? This one is the feasible area. Feasible area. Okay, that is a feasible area. Not the other way. Okay, now you have to get one point here. This point. Okay, so you have A, you have B, and you have point number C. Point C is 45 comma 0 and A is 0 comma 40. Okay. Uh, 40 C is 45 comma 0. Then B only you have to find. Okay. How to find B? Solve for equations 4x1 plus x2 is equal to 40. You solve it with 2x1 plus 3x2 is equal to 90. What to do? Multiply this by 2. Okay. So 4x1 plus x2 is equal to 40. Multiply by 2. 4x1 plus 6x2 is equal to 180. Multiply. You do it the other way around. 4x1 plus 6x2 is equal to 180. 4x1 plus x2 is equal to 40. Now you subtract. Okay, 4x1 will go off. 5x2 will remain. 140 it will be. So x2 is equal to 140 by 5. How much that will be? 140 by 5. 28 into 5. 40, 10, 40. Okay, it's 28. X2 is 28. Okay. Now you find out 2x1. 2x1 plus 3 into 28 is equal to 90. Correct. You substitute x2 equal to 28 there. Okay. So 2x1, 28 is 56 is equal to 90 minus 3, 28 into 3. How much is that? 3, 24, 6, 84. Okay, 98 minus 90 minus 84 is equal to 6. 2x1 equal to 6. x1 is equal to 6 by 2 is equal to 3. So the point is 3 comma 28. 28 and 3. 3 comma 28. This is the point is 3 comma 28. Okay. The point is 3 comma 28. So now you have to find out which of these three is the greatest. For which equation? Let us erase off these things. Okay, now we'll find. What is the function we have to minimize? 5x1 plus 4x2. That only you'll have to minimize. So 5 into 0 plus 4 into 40. How much is that? 160. Correct. $160. Then another point, 3 comma 5 into 3 plus 4 into 28. 5 into 3 is 15. 4 into 28. 28 into 4, how much? 32. 2 fours are 8. 112 plus 15. 7 to 127. This is equal to 127. Okay. Then C is equal to 5 into 45 plus 4 into 0. 5 is 5 into 45. 5 into 45 is 5, 25, 22, 25. So that is equal to 225. Okay, which of this is smallest? 127 is smallest. So Z min is equal to 127, where x1 is equal to 3 and x2 is equal to 28. Okay, that is the answer. So this is how you have to write the answer. 1 second, there is some noise. I will come back. Okay, you got that? It's the same thing your textbook is giving, but we are just solving it ourselves. Okay. So this is minimum, smallest number of 160, 127, 225. 127 is smallest number. What are the values of x1 and x2 for the smallest number? Values are 3 and 28. So x1 equal to 3, x2 equal to 28. At that time, z is a minimum of 127. Okay, that's all you have to find now. So you now know how to do for maximum and how to do for minimum also.
Minimum, okay.
Yeah. Okay. Now let us do all the following and LPP, that is maximizing function. Okay, maximizing function. Let us do 10.7 and see how to maximize. Okay. So example 10.7 is telling maximize z equal to 2x1 plus 3x2. Okay. Subject to constraints x1 plus x2 less than or equal to 30. For you ignore the less one. Then x2 equal to 12 and x1 equal to 20. And this one always given x1 greater than 0, x2 greater than 0. So they are in the first quadrant always. Okay. Now what is this whole thing? Okay. Only for this you have to find x1 and x2. Okay. x1, x2 is a line and x1 is a line in a way like this. Okay, x2 is equal to 12. Okay, let us say 2, 4, 6, 8, 10, 12. Okay, when x1 equal to whatever value x1 equal to 2, 4, 6, 8, 10, 12. x2 equal to 12. So it is a line that is parallel to the y-axis like this. Okay, this is that line. Same way x1 equal to 20. Whatever value of x2, whatever value 1, 2, 3, whatever, no, x2 value. x2 value is 2, 4, 6, 8, 10, 12. It doesn't matter. x1 will always be no. X1 values are whatever. Okay, x1 is 2, 4, 6, 8, 10, 12. Okay, x2 will always be 12. 1, 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, and 12. Okay, that means this is that line. This is the line x2 is equal to 12. This is the line x1 equal to 20. Okay, these two lines. And then there is a third line which is a sloping line. Okay, x1 is equal to 0 you put, x2 is equal to 30 it will come. So 0 comma 30 is 1 point. Now x2 is equal to 0 you put, x1 equal to 30 it comes. So 30 comma 0 is the other point. 0 comma 30 to 30 comma 0, that is what it is fitting in. Okay, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay, so this is x1 is 0 comma 30. 0 comma 30, this is what? 2, 6, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay, this is 30 comma 0. Okay, this line is joining these two. Like that it is joining. I think I made a mistake. x2 is equal to 12. Right, x2 is equal to 12. 1, 2, 2, 4, 6, 8, 10, 12. Yeah, this is correct. x2 is equal to 12 is correct. x1 equal to 20 is not correct. 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This one only correct. So this one only correct. So this is meeting at this point. This is meeting at this point, this point, and this point, this point. So, which is the feasibility region? This becomes the feasibility region. Okay, feasibility. This is A, B, C, D, E. So 2, 4, 6, 8, 10, 12. This point is 0, 12. Okay, this point is 0, 12. What is this point? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This point is 20, 0. Okay. So that is also easily known. Okay. Now we have to find C and D. How to find C and D? You have to find the intersection of, okay, x1 equal to 20 intersects 30 comma x1 plus x2 is equal to 30. Okay, that one you have to find the intersection of that. Okay, so x1 equal to 20. You subtract this from this. Okay, this one goes x2 is equal to 30 minus 20, 10. Okay, so x1 equal to 20, x2 is equal to 10. This 1 point. So 20 comma 10. This one is 20 comma 10. This is 1 point. Okay. What about this other point? This one is the intersection of x2 equal to 12. This line with this line. x1 plus x2 is equal to 30. This both time. Okay. Again, you subtract x1. This will cancel off. x1 equal to 18. Okay. Then x2 is equal to 12. So this is 18 comma 12, this point. 18 comma 12. So D is 18 comma 12. Now what is telling? Example 8.7. Feasible region. Z must be maximized. So Z max you have to find. Okay. What are the points? This one is 0 comma 0. Okay, 0 comma 0. A, B is 20 comma 0. C is 20 comma 10. D is 18 comma 12. And E is 0 comma 12. Okay. So now you have to find the Z max function. Z max function is 2x1 plus 3x2. Okay. So 2 into 0 plus 3 into 0 is equal to 0. 2 into 20 plus 3 into 0 is equal to 40. Then C1 is 2 into 20 plus 3 into 10 is equal to, this is 40 plus this is 30, 70. Okay. Then 2 into 18 plus 3 into 12. 2 into 18 is 36. 3 into 12 also 36. That is equal to 72. Then fifth one, 2 into 0 plus 3 into 12. This point is 0 comma 12. So that is equal to 36. Of this, which is greatest? 72 is greatest. Therefore, Z max is equal to 72 at x1 equal to how much? 18 and x2 is equal to 12. Okay. This is the maximizing function. That's all we have to say. So this is the third problem we have solved. Okay. Okay, fourth one, let us do it on the textbook itself. Okay, fourth one, let us do it on the textbook, and then we will take up at least one exercise sum and complete it. Fourth one is simple. The point of fourth one, where is fourth one? Example 10.8. Example 10.8, maximize z equal to 3x1 plus 4x2, subject to x1 minus x2 is equal to minus 1 is telling, and minus x1 plus x2 is equal to 0. Okay, those are the two functions. Now look at these things. Okay, x1, x2 is greater than 0, no problem. It must be in the first quadrant. Okay. Now consider this equation, x1 minus x2 is equal to minus 1. And x minus x1 plus x2 is equal to 0. Okay. Now, if you put the point, okay, x1 equal to 0, then minus x2 is equal to minus 1, x2 is equal to 1. So this point becomes 0, comma 1. Okay, so this point is correct. Okay, now the other equation is telling us x1 minus x2 is equal to minus 1. Okay, the other equation is x2 minus x1 equal to minus 1. Okay, now here you put x1 equal to 0, minus x2 is equal to minus 1. So x2 is equal to 1. Okay, so here also you get wait, we will do it from the beginning. Equation is, first equation is x1 minus x2 is equal to minus 1. So when x1 equal to 0, minus x2 is equal to minus 1. So x2 is equal to 1. So this point becomes 0, 1, first point. Okay, A, first point is 0, 1. Now x2 is equal to 0. Okay, that means x1 equal to -1. So that means -1, 0 is the other point. 0, 1 and -1, 0. Okay, that is correct. Now this is a line which is 0, 1. 0, 1 is this point, and -1, 0. -1, 0 is this point. So the line is like this, it's going like this. Okay, it is in the first quadrant, so you must extract it and push it into the first quadrant. You cannot be dealing with it in the, this becomes second quadrant, so you can't deal here. Only in first quadrant you have to deal, because x1 greater than 0 and x2 greater than 0. Now look at this other line. Okay, the other line is -x1 plus x2 is equal to 0. Here put x1 equal to 0, then x2 is equal to 0. Okay, x2 equal to 0. So this one becomes 0, 0, 1 point. So this one 0, 0. This is 1 point. Okay, that is when you put x1 equal to 0. Now you put x2 is equal to 0. Okay, minus x1 plus x2 is equal to 0. x2 is equal to minus x1 equal to 0. So again you get 0, 0. Okay, now this is a line passing through. Here is a problem. Okay, here is a problem. This other one is only passing through the point 0, 0. We don't know which way it is going. We don't know which way is going. Okay, it is passing through 0, 0. That's all we know. Now, that is why we can draw the graph satisfying the conditions, these two conditions. There is no common feasible region satisfying all the given conditions. How will you draw this line 0, 0? Okay, that is a problem. So there is no feasibility region at all that you will get for that. Okay, that means these two equations do not have a LPP solution at all. Okay, so that is the thing. So this is example 10.8 is a freak example. Be very careful about example 10.8 like sums. Okay.
Uncle, how do you like draw the diagram for the graph diagram?
This graph is drawn like this. No, you draw like this itself. 0, 0, 0, draw it parallel to that. These two lines will never meet. Okay, that's
Okay.
what. So you draw it like that. Then no feasibility region will come, because there are two regions. One region is going like this.
Okay.
You don't have to draw the graph actually. One region
Okay.
is going like this. Okay, another region is going like this. So this is not a correct feasibility region at all. Okay, because the two lines must intersect. This must intersect, this must intersect, then you will get a nice feasibility region like this. Okay, here you are not getting feasibility region because they are just going parallel. Okay, so that's why you say these two lines are in such a way that there is no common feasible region at all coming, just satisfying the two constraints. So no LPP maximizing solution is possible. Okay, so because we cannot draw the feasibility graph at all. No feasibility graph itself is not appearing, and no feasibility region is appearing. So no solution for maximizing or minimizing or anything optimizing Z is not possible. Okay, that's all you do. Now let us go to exercise 10.1. At least we will do first sum. Okay, let us do the first sum, and I think our time will be up. Exercise 10.1, sum number 1. A company produces two types of pen, A and B. Okay, two types of pen, A and B. Pen A is of superior quality, pen B is of lower quality. Okay, profits on pen A and pen B are, okay, now we have to assume how many units of pen A it's producing. Decision variable 1 is x1. How many units of pen B is producing? Units produced, let us say B1 they produced x2, and B1 they produce x1 units of pens. Okay, number of pens. So these are the decision variables. Profits on pen A and pen B are ₹5. So total profit on pen A, okay. How many units of pen A are selling? X1 units into 5, okay. That is the total profits on pen A. Then pen B, okay, you are telling how many? ₹3 for each pen B are, but how many pen B you are selling? You are telling selling X2 units of pen B. So total profit will be 5x1 plus 3x2. So this will be your Z function, okay. And you have to maximize this Z function. Z max is equal to 5x1 plus 3x2. Okay, you have found out the object function. You found out the decision variables. You found out the object functions. Now you have to go and look at the constraints. The supply of raw materials. Supply of raw materials is sufficient only for 1000 pens per day. Okay. So that means then let us see, only less than or equal to 1000 we have to put. Raw materials required for each pen A is twice as much of each pen B. Okay, that means 2 times the raw material, let us say 2 grams is required for each pen 2 into x1, okay. And x2, and it is not, no, only one unit is required. 2 units are required for x1, 1 unit for x2, okay. So totally it must be raw materials is sufficient for only 1000 pens per day, okay. We don't know what grams or kilograms raw materials are given. So you just write this constraint 1, C1 like that. C2, how you have to write? Pen A requires a special clip and only 400 such clips are available per day. Okay, that means each day you can produce only 400 pens of type A because only 400 clips are available. For pen B, only 700 clips are available. So number of units of pen B you can produce also reduced to only 700, okay, because you cannot produce more than 700. So this is also a constraint. The other negativity constraints will be x1 must be greater than 0 and x2 must be greater than 0. Okay, this is your whole mathematical solution. So you must say z is equal to 5x1 plus 3x2 such that constraint C1, C2, C3, and C4 are satisfied. Okay, this is the solution. That's all. Very simple sum. Okay. You understood the sum. If you understood it, we can go and do sum number 2 also. Let us do sum number 2. Then means you can do sum number 3 for homework.
Okay, okay.
This is sum number 2. Easy only, no? You thought it's all very tough and all, but it's easy.
Uncle, it's light or tough only, uncle, the graph part. I mean, like, drawing the
Graph
graph, drawing the graph is only easy, uncle, but like finding the values of it is a bit.
Yeah, graph part is, but it's interesting. You can get correct, accurate answers because there you have to give the value of z max or z min. So that function, you'll have to substitute x1 and x2 values and find out what is maximum minimum. But this problem, non-graphical problem, you have to give only the mathematical model. You don't have to find the maximum value. Okay. So let us do exercise 10.2. Okay, 10.1, sum number 2 we have to do. A company produces 2 types of product, A and B. Again, A and B are 2 types of products. Profits on the 2, let us say x1 units of A is produced, x2 units of B. This is the decision variables. Profits on the 2 types of products of 30 and 40 rupees. So total profit on selling A will be x1 units of A, each at 30 rupees profit you are selling. Then same way, 40 rupees profits you are selling x2 units of B. So we want to formulate this problem as a linear programming problem to maximize the profit. So Z function will be maximizing this. Okay, maximize this. So you found out Z function, decision variables you found out, x1, x2. How to maximize you found out. Now let us look at the constraints. Okay, first constraint. Raw materials. Okay, raw materials. Capacity available per month for raw materials is 12,000. If you have to maximize, then the constraints will be minimized. If you have to minimize, the constraints will be maximized usually. Okay. Product A, for product A, raw material 60 kg. Okay. So 60 kg for one product A into how many products? X1 products. Okay. Then 120 for product A, 120 kg for product B. How many products? X2 products. So this is one first condition. Then condition number 2 will be 8 machine hours for how many products? X1 products of type A plus 5 machine hours for X2 products of type B. Totally should come then less than 600 machine hours. This will be less than kgs, 12,000 kgs it will be. Constraint 3, assembling of man hours. Okay, man hours needed for assembly. 3 man hours for each product. How many products? X1 products of type A. Okay, and then you're saying assembling man hours is 4 hours for each product of X2. So how many products? X2 type into 4 man hours. So totally the man hours must be less than 500 man hours only available. So then the other one is X1 greater than 0 and X2 greater than 0. Okay, this is all the conditions. So you have to write subject to maximize Z. Okay, subject to following constraints. That is all there is to sum number 2. Okay, very good. We finished it. I am going to post this. Is it raining in your house, man?
Yeah, it's raining.
Oh my God, it's raining here also.
Yeah, I don't think so. It will stop, uncle. Now
Huh?
only it
Too much
started.
rain, huh? I have to go now, man. Go to Attipet. How I'm going to go, I don't know.
Auto, uncle.
Okay, thank you very much.
Sure,
We
uncle.
finished 2 sums. I didn't expect to finish the 2 terms.
Hmm.
You try sum number 3 for homework. Okay.
Uncle.
And come fourth sum, we'll do some 3 sums, and you can do homework some sums.
Okay.
Next class we'll do. Then we'll move to network analysis. Network analysis even more interesting. Okay, all this advanced mathematics that I got taught only in my 5th year in Bachelor's of Architecture. Network analysis I learned in my final year, 5th year in architecture I learned. You're learning now itself. Okay, bye bye. Enjoy the weekend, man.
Sure, uncle. Bye, uncle. Go safely.
Sorry?
Go safely, uncle. You're going out now.
Yeah, that is
sure.
at least 10 kilometers you have to go. After
10
Ambattur.
kilometers, uncle.
Ambatturலாம் தாண்டி. Okay.
Wow. Okay.
Okay.
Bye, uncle.
Bye, man. Bye bye. I hope
Be
you
safe.
enjoyed.
Bye.